This video is about the orbital motion of the objects in the solar system. The planets in the solar system orbit around the Sun in nearly circular paths. In order to maintain these circular paths, there has to be a force keeping them in orbit. This is called a centripetal force. The centripetal force that keeps the planets in orbit is the gravitational attraction of the Sun. This force always points towards the centre of the circular path and acts at right angles to the velocity. When showing the gravitational force acting on an object, always draw the arrow from the smaller body to the larger one. This is because gravitational forces are attractive and always act towards the centre of the larger body. The size of the gravitational force between objects depends on the size of the masses involved. This means large masses such as stars and planets produce large gravitational forces. The Sun contains over 99% of the mass of the solar system. Therefore, it produces the largest gravitational force out of all the objects around it. The size of the gravitational force also depends on the distance between the masses. As the distance between the objects increases, the smaller the effect of gravity becomes. The planets closest to the Sun experience the strongest gravitational attraction, whereas the outer planets experience the weakest. This reduced force has an effect on the orbital speed of an object. The weaker the force, the slower the orbital speed. Therefore, the planets closer to the Sun travel faster, and the planets further away from the Sun travel slower. Make sure you can explain how orbital speed decreases with distance, as this can come up in an exam question. Let's try an example question. Two satellites, X and Y, orbit the Earth at different heights above the surface, as shown in the diagram. Compare the orbital periods of X and Y. So, for 3 marks, we need to compare the two satellites, X and Y, in terms of their distance or height above the Earth, their orbital speeds, and their orbital period. First, let's pick one of the satellites to focus on, and first look at its distance above the Earth's surface. Satellite X is further from the Earth than Y. This is a simple observation, but it is an important point and makes it clear to the examiner which satellite you are focusing your explanation on. We know that gravitational field strength decreases with distance, and that force is proportional to speed. So, as the distance from the Earth increases, orbital speed decreases. This means satellite X has a slower orbital speed than Y. And finally, as distance increases, orbital period increases as speed is inversely proportional to time. This means satellite X has a longer orbital period than Y. This makes sense because satellite X has a much longer orbital path around the Earth than Y, so naturally it will take X longer to complete one orbit. In a compare question, you have to write down similarities and differences between two objects or things. Make sure you refer to both of them to get all the available marks. In summary, gravitational attraction is responsible for orbital motion. The gravitational force always acts towards the centre of the circular path, from the smaller mass to the larger mass. The size of a gravitational force depends on an object's mass. The greater the mass, the greater the gravitational force it produces. The strength of a gravitational field also depends on the distance between the masses. As distance increases, the gravitational force decreases. The orbital speed also decreases, and the orbital period increases. Don't forget to check out all of our other fantastic revision resources here at Save My Exams.